In this video, we will look at the Excel regression analysis output and try to recognize the statistic from this output. So the first I want to mention, if you don't know how to get this output, you need to go back to watch the video called How Can You Use Excel to Do the Regression Analysis. After you know how to get this output, and we can see what kind of statistic we can find from this output. So any Excel regression analysis output are made up by 4 parts: regression statistic, ANOVA table, and the linear regression equation, and residual analysis. And so the following parts of this video, I will give you detail for each part of this output. So first, let's look at the regression statistic table. So the first statistic called multiple R, and the multiple R if we try to connect the multiple R with what we learned in the class, and you should recognize that the multiple R actually is our coefficient of correlation. So it's R, and so you will get 0.9366. But what I want to see is this is not correct most of the time, because the multiple R is the absolute value of R. So in order to correctly get the correlation, you need to check the sign for the slope. And later I will mention where is the slope in this table, in this output. But again, you need to know the multiple R actually is the absolute value of our R, the correlation. In the second statistic, you can look at the following. The multiple R is called R square. So in the class, we learned R square, which stands for the coefficient of determination. And I suggest you that you usually convert it to the percentage, because when you interpret the R square, we will usually see our percentage of variation in Y is explained by the regression model. So for this example, we can find 87.72% of variation in the number of the cars sold is explained by our regression model. So in the first, so this is the two statistics you need to pay attention in our first table. And third statistic you need to notice is the standard error. So the standard error here is what we learned in our class is the S. Is the standard error for our regression model, and we will use it to do the calculation for confidence interval and prediction interval for the Y. So you need to know multiple R, R squared, and standard error in our first table from the regression output. And the second table called ANOVA table, and you'll find that there are 3 lines: regression, residual, and the total. And what I want you to pay attention is the column called SS. And in the class we mentioned the SST equal to SSR plus SSE. Some square error total and equal to the sum square error due to the regression model, and the sum square error due to the error term residual. So that's SST equal to SSR and SSE. And you can find the 3 statistics from the second part of the Excel output, ANOVA table. So the SS actually is the first 2 letters for our SST, SSR, and SSE. So the SS regression here, the 100 actually is SSR. So some square error caused by the regression model. In the second row, residual. So so the second row actually is SSE, and the last one, 114 here, is SS total. So SST. And as we know that if we are using the SSR divided by the SS SSR divided by SST, and we will get our get our R square. But also we do the F tests to test the significance of the whole model, and we're using the F statistic. So here 21.4286 is our F statistics, and 0.0190, that is the p-value corresponding to our F statistic. So in this table, you need to know where to find F statistic and the significance of F, because you are required to do the F tests to test the significance of the whole model. And also you need to know where to find SSR, SSE, and SST. Everything is coming from the second part of our Excel output. Now let's look at our third part. It's a very important part. So this part actually tells us how our regression model equation looks like. So the first, you will find, no matter what the data set you have, the first row always called the intercept. So the intercept in our linear model actually is a B0. And the TVX, although it's a name for the X, but actually they are calculating the value for B1, which is the parameter ahead of your X. So the B0, the coefficients actually is for B's. So 10 is B0, 5 is the B1. So if we write down the regression, if we try to write down the model, so we will have y hat equal to our 10, which is B0, plus 5 times x. So this is our estimated regression equation. So that's the first part you need to pay attention. So now you will know that the 5 here, the coefficient for the TVS is our slope. Since the slope is positive, then if you go back to look at multiple R here, so the absolute value is equal to 0.9366. So the R is equal to 0.9366 because the sign for our slope is positive, so you don't need to change it. That's the first you need to take attention. And the second is, if you look at the column D called T-stats, so and the column E, the p-value. So we use T-stat and the p-value to do the t-test to test the significance of our slope. So we said if the t-statistic is larger than the t-statistic, you look it up from the t-table, and we will reject H norm. And the same if the p-value is smaller than 0.05, and we will reject the p-value. So here the t-stat and the p-value is the value you will use to do the significant test for the slope. And if you look at the E, F, and the G column, which is following the p-value, you have the lower 95% and the upper 95%. So they are the boundary for our slope, beta 1. So corresponding to the second row, TVS, and you will have the lower band is 1.5626, and the upper band is 8.4374. So you will have the confidence interval for our slope is between 1.56 to 8.4374. So that's the confidence interval for the slope. Since 0 is not included within this interval, then we will know the slope is significantly different from 0.